All right, welcome back. Well, in this tutorial, we're going to go through some examples of how to use the fundamental theorem of calculus, or specifically how to use the part one, taking the derivative of the integral, which is the derivative of the antiderivative. Okay, so essentially, this is what we're going to be doing. We're going to be taking, all right, we're going to be finding what is dy dx. What is dy dx? All right, that means we're going to be taking the derivative of y. Now, to do this, I have a certain, all right, thoughts on how to do this properly and how to think about this. We know that we have this, the derivative of the integral equals a function inside. However, that can be sometimes confusing if you just think about it that way. So we're going to use both, all right, part 1 and 2 of the fundamental theorem to help us understand this a little bit better. All right, so what we're going to do is we're going to write this out, and you have to understand the concept that we have here. When we take the integral of this function, this is saying this equals y. Y then has to be our antiderivative. The antiderivative is a function that will give us the area underneath the curve. So that's what y is. It's the antiderivative of, all right, the square root of 1 plus t squared. Now, I don't know what that function will be because it's a little bit hard function to figure out, but that's what it would be. Now, if we write this out, we would have, if we integrate this from 0 to x, we would actually have y of x minus y of 0. That would be our proper integration if we knew what y would equal. Now, we want to figure out what dy dx is. So we're going to figure out by taking the derivative of this function, all right, of this function right here. So when we do that, we're going to take the derivative. I'm not going to necessarily look at this, but I'm going to look at this right here. That means I'm going to take the derivative of y prime, of x, minus the derivative of y prime of 0. All right, now, y prime of x, the derivative of our antiderivative, if you recall, equals the function inside. And since we have x right here, y prime of x should equal 1 plus, well, we're going to plug x in for t. We have x squared, and that's going to equal that value. Minus the derivative of y of 0. Now, y of 0, this value right here is a constant. That's a constant. So what we have right there, the derivative of a constant is going to equal 0. So that means simply the derivative of y, which equals this integral, is simply going to equal the value inside with respect to x. And that's our answer. Let's go through another one. Okay. Applying the same thing, this one changes a little bit. Unlike the previous ones that I've gone through, is that if you notice, we have a different upper limit of integration. Well, we're going to start the same way. Y equals the integral from 0 to square root of x of sine of t squared dt. Y is the antiderivative of sine of t squared, because that's what integral does. Integral gives us the antiderivative, which is the area of the curve. So we should have y of the square root of x minus y of 0, if we did the fundamental theorem of calculus, right? Upper limit minus lower limit, that's what we got. We want to figure out what dy dx is. So I'm going to take the derivative of this entire thing. So let me get a different value. So I'm going to figure out the derivative of this with respect to x. All right. When we do that, yes, this will turn into dy dx. So dy dx is going to equal the derivative of y composed of the square root of x. Now, since I'm taking the derivative composed of another function, guess what we have to use to find this derivative? Hopefully you're saying it with me. Yes, whenever you do a composite derivative, you have to use the chain rule. So we're going to use the chain rule here. The derivative of y is going to be y prime of the square root of x times now the derivative of the square root of x, which is 1/2 x to the negative 1/2 power, using the chain rule, minus y prime of 0. Well, y prime of 0, once again, this is a constant. That means it's a number. And the derivative of any number, well, how do you know that? Some students ask, well, how do you know that? Well, it's y of 0. Remember, y is a function. We're plugging in 0 in there. We get a number. All right? Since we get a number, the derivative of any number is 0. So what we have then is, let's simplify this. We're going to have this, well, y prime, the antiderivative, is going to equal the function inside. So it's going to equal sine of, remember, square root of x. We're going to square it. So we're going to have the square root of x squared times now the outside, which will be 1 over 2 times the square root of x. We have that right there. Minus 0. If you want to simplify this, because that right there is going to equal 0. So if you want to simplify it, the square root of x squared, that's going to be the sine of the absolute value of x, because it has to be positive all the time. All right, we'll put that there. All over 2 square roots of x. Simplify that, and that would be our solution. All right, that's using fundamental theorem. So we're using both concepts to help us understand this a little bit more fully. Let's do one more, and then I'll do some more on another tutorial, but we'll finish up with one more. All right, see if you got this down. So taking this one, you're going to, once again, we want to find the derivative of this. But before we do that, let's just write this out. Okay, this is how I always start these problems. So y has to equal the antiderivative of this, because the integral means I'm taking the integral, which means I'm finding the antiderivative of cosine of 2t. That's going to equal y. Well, we're integrating from x squared to x cubed. So we have y of x cubed minus y of x squared. We're now going to take the derivative of this. Why? Because it asks us to. So we want to find what is the derivative of y. When we do that, we have dy dx. That's going to equal, we'll have y prime x cubed times the derivative inside, because remember we did a chain rule because we have something other than x inside there, 3x squared. Remember chain rule, chain rule. Well, here we're going to subtract. Now we have y of x squared. Hey, this is different than all the other problems, because if you notice all the other problems, what we have was a, which is a constant, 0 constant, 0 constant. In this case, we don't have a constant. We actually have x squared. So we take y prime of x squared. Chain rule again. What's the derivative of x squared? 2x. That's what we got. Well, let's simplify this into what we know. The derivative of y is going to equal the inside. So we'll have cosine of 2 times, well, what's inside? We got x cubed. We're going to replace that with t, 4t that is, times 3x squared, minus y prime. Y prime, remember the derivative of the antiderivative equals the function that you just integrated. All right, so it's going to be cosine of 2 times what is inside there, x squared. All right, times 2x. Probably factor out if we wanted to the 2x or x actually. Well, we'll just leave it like that. And that's our answer. All right. So once again, the derivative of an integral equals a function inside. Make sure you set this up, all right, and use a chain rule when it's not just simply a constant or x. You have to use a little bit more. So apply what we know about the fundamental theorem. Upper limit minus lower limit. The derivative of the antiderivative equals a function inside. But make sure you look at these limits of integration before you do it. All right. Hopefully this helps you out. We're going to do some more tutorials on this in just a little bit. So good luck and God bless.